Alright, so we have learned how to find first derivative, using first derivative to find critical numbers, and then test the sign to see to find relative max and relative min. Then we also learned to use second derivative to determine to find point of inflections and then determine concavity, whether it's concave up or concave down. For this example, we're going to combine those two together. So with that said, first of all, we're going to find first derivative. So first derivative, f prime of x, which is going to be negative 15 x to the fourth power plus 15 x squared. Then we set this equal to 0 and solve for x values. That is the critical points that we want to find. So set that equal to 0. So x should be equal to 0, positive, and negative 1. Then what we do next is that we're going to set up our table using the critical point. So the first critical point that we used, and now we have 3 of those, so the first one that you use is x equals 0, x equal negative 1, x equals 0, and then x equal 1. Remember when we use first derivative test, we actually set up an interval. And then we determine if that interval is increasing or decreasing, and then we determine the point, the critical points, based on the derivative, we determine whether it's relative max or relative min. The same thing with second derivative, we set up the interval. Then we determine if that interval is concave up or concave down. For this one, when they ask you to find relative extrema using second derivative test, so instead of set up the interval like we used to, we actually use the critical values that we just solved for. Then what we need to do is take second derivative, which just give you negative 60x squared, negative 60x to the third power plus 30x. So for this one, we can factor it out, which is what I see is I can take out the negative 30x. So I have 2x squared minus 1. Okay, so what we do is that, now remember, we actually, before we solve for the inflection point, this one we don't have to. If they're asking to find relative extrema, they're not asking you to find concavity, then we don't need to set that equal to 0 and solve for it. What you actually can do is that you will use the critical points and plug it back into the function to figure out what that is. Alright, so what we're going to do is that for this one, keep in mind we're using second derivative. So right here, what we need to do, sorry, I'm not sure why I keep moving. What we need to do is find in, we can plug it in to second derivative. Okay, so at this point right here, we check in. What we do is we take negative 1, plug into second derivative. So f prime, double prime, if you plug it in, negative 1 here. The sign that you would get if you plug it in, so we have negative 60 times negative 1 minus 30, so that would give you a negative values. So that would be negative, okay? what we can do, another one, is that we plug in the 0 again. We plug it in because we use in second derivative. So we actually use a point and plug into second derivative. If I put in a 0, here's the thing. Sorry, I'm not sure. Sorry about that. So if you plug it in, it's actually equal to 0. And now this is the point that we're going to come back and check, because when it's equal to 0, we're not sure what that means. So this is the point that I'm going to make a star right here. So sorry about this. I'm going to make a star right here that we can go back and check. So I'm doing the same thing for the last point, which is I plug in here. So this is negative 60 plus 30. If you plug in 1, if you substitute the x values of 1 into second derivative, so I have negative 60 plus 30, which will give you a negative values. So by look at this, we can see that right here, because it's negative, we can say it's relative max. And I just make a mistake for x equal negative 1. So if I put it in negative 1 times negative 60, that's positive 60 minus 30. So this will give me positive. I apologize. I didn't do my math correct. So over here, if it's plus, that would give you relative min. So probably you was like, how so? Well, think about second derivative is talk about concavity, right? So if this is concave up, this is the picture that's concave up. So if you look at this point, if it's concave up, the point, if you look for this one, you can see that if it's concave up, the point is the lowest point. So that's what gives you relative min. Over here, this is concave down. So you can see that when this would give you a max, which is the top of the hill. That's how we need to imagine that, okay? So for this one, it's a bit confused. So let's review the step. So step 1, we take first derivative, we solve for the critical point. We actually use the critical points instead of setting up interval like we used to. Then we take second derivative. What we do is that we use the critical point. Keep in mind the critical point, not point inflection, to substitute into second derivative and test for the sign. So the first one is positive. The second one is equal to 0. Like I said, we will come back and check for that point to see what happened at that point. Then the third one is 1, which gives you negative. So think about when it's concave down, it will give us a max because that gives you the hill, top of the hill. And then if it's concave up, it actually gives you the min. So this is pre-cal, this is algebra 2. Think about quadratic function and we talk about the vertex and we look for max and min, right? Okay, so now like I said, we will go back and check for when the critical point is 0. Because when the critical point, when x is 0, we use a second derivative and it still gives us 0. So that doesn't help us. I don't know if that concave up, I don't know if that concave down. So what we have to do is that we actually have to go back and use first derivative. And this is a time, if it's not working, if you use second derivative and it's not working, we actually have to go back and use first derivative. And now we have to set up the interval. Okay, so this would go from negative 1 to 0, and then 0 to 1. So keep in mind the point that we want to test is the 0. That's why I don't set up the interval from negative infinity to negative 1 or from 1 to positive infinity, because we already know what happened at those intervals. What we need to test is the 0. So that's why I'm only checked what happened to 0. So I'm using these two intervals. So the test values, again, so this one we can use first derivative test. So we use first derivative test. Alright, so the interval between -1 and 0, I would use -1/2. Between 0 and 1, I would use 1/2. So this is the time you use the first derivative. So you would substitute in the -1/2 into first derivative, which will give you a positive values, and this would give you a negative value. Sorry. Also, I did it wrong. With 1/2, plug it back in. That would also give you a positive. So right here, if you see the slope is increasing from the left and also increasing from the right, it will neither give you a max nor min. So neither max nor min at 0. Okay. Alright, so this is a lot of information, but we'll take questions on Monday. And I'm hoping that as you listen through this, write out your own notes or question that you may have for me or Ms. Conant. So when we go over this on Monday, you can ask questions about the steps. Alright, so now let's go to the next example, which is when they give you a table and we will identify what kind of graph and when is this going to be a max, when is this going to be a min. Instead of look at the graph, we just look at the table instead. Okay, so this is the table they gave us the x values. That's the first row. So the x values on the graph. And then they give the second one, which is f of x, or we can say that is the y values, okay? And then the third line is f prime, so that is the slope or derivative, okay? So I would put down slope. And the last one is second derivative, so that would be, we talk about concavity or acceleration, or we talk about concavity, okay? Alright, so the first one is identify x values where f have relative minimum. Alright, relative minimum. This is when we use first derivative. So think about minimum. This is the kind when you have a minimum. So if you look at this one, right? So we use slope. It's decreasing. It goes from decreasing to increasing. So what we need to do is that we're going to go to, because this is involved slope, so I'm only focused on the slope, right? So I'm looking only at f prime and see where they change the derivative from negative to positive. And so how do we check that? So keep in mind we go from negative to the slope is 0, then positive. And we want to see where do we see that. So I'm looking at the first one. This is positive, then 0 and -1. It doesn't fit this description. But I'm start looking right here from -1. I highlight that. It looks like I crossed it out, but I meant to highlight that one. It's the -1. If you look, it's -1, 0, and then positive, which is fits the description here. It goes from negative, 0, and positive. So what you can see is that it's happened, and the x values that you want to focus is when it's at 0, right? So which the x value is 3. And when they asking you to justify, what you would say is f prime of x is change from negative to positive. And that is the part at f equals 3. And that's the part where they ask you to justify. So you explain because the slope, when you say f prime, instead of say derivative or you say the slope, you can say f prime is changing from negative to positive. All right, let's look at the next one. I want you, if at this point, I would like you to pause the video for about a minute or two, and I want you to try B on your own first to see if it kind of makes sense to you. Think about relative maximum. I just went over relative min. So that's a challenge for you. Just pause the video at this point and see if you can identify where they have a max. And then play to see if you actually got it. So again, let's talk about maximum. So let's pause and see what, okay? Alright, so hopefully you try that. So maximum, if you think about maximum, this is the shape. So we start from positive slope, and then we have 0, and then negative slope. Okay, and we want to know what is the x values that will give you the slope. When this is the point, because we want to know this is the point that we want. That means when the slope is equal to 0. Okay, so positive to negative. So I'm looking from the slope from positive to negative is right here because flow from positive 1 to negative 1. And the one that I'm paying attention to is when the slope is 0, because this is the point that I want. When the slope is 0, x is negative 1. So I can put down x is negative 1. And the part that you justify is say f prime change from positive to negative when x equal negative 1. Alright, so the next one that we looked at is identify the x values when we have point of inflection. So let's review. Point of inflection is when secant derivative is equal to 0. So now I'm actually looking at secant derivative. And I'm going to highlight, I'm going to erase all the part that I circle so we can make it easy to go back. So I will look at secant derivative when it's equal to 0. So right at this place, right? And they want the x values. Sorry about that. So if I look at the x values, when secant derivative is 0, is the x values is 1. So x is 1. And the second place that secant derivative is 0 is when x is 7, right? So these are just two places that I will look at. But to have the point of inflection is actually when secant derivative is changing concavity. So not only secant derivative equals 0, but also is change concavity. So that means it's either go from concave up to concave down or from concave down to concave up. So sorry, let me rewrite this just in case. So point inflection is when secant derivative is equal to 0 and change concavity. Okay. So I look at this one. I have 2 points to pay attention to. But I'm not going to be able to use x of 7 because if I look from the left and the right, secant derivatives have not changed the sign at all. As they both positive to positive. So I won't use that one because it's not changing sign. But what I will see, the only place it's changed sign is when x is when the secant derivative, I look on this side is negative and it changed to this side is positive. So the x values when it has point of inflection is when x is equal to 1. Because if we looked at it changed, and so I'm giving you an example. So this is changing from concave down to concave up. That's what it means. So point of inflection is when it changed concavity. So we look at the second derivative change in sign from, it doesn't matter, it can be from positive to negative or from negative to positive. As long as the change, we call that point of inflection. And then if you look at when x is equals 7, this one is concave up. If I draw this sketch, it's concave up. I'm sorry, I'm doing the opposite. It's concave up, and then it's concave up again. So that's not the point of inflection. It's neither. Okay. The last one is, sorry, before I move on to the last question, I just make sure that again, jot down questions that you have so we can go over this on Monday. And I apologize for this note. I've been like, it's a long video, but I think there's a lot of information that I want you to know, and it's important because we're going to continue to use the skills for the next couple weeks, and you will end up making some videos. You're going to do your projects, your tests, your quiz. We do a lot with these, so make sure that you have question ready for us. So the last one is asking for equation of the tangent line. So let's review. Equation of the tangent line is it's a straight line, and we can use point slope or slope intercept. In this case, I'm going to use most of the time in calculus, we can use point slope, right? So equation of tangent line when x is 5. Okay, so what I would do, again, I'm going to erase what I write on the table. So when x is 5, this is the column that I'm looking for. So when x is 5, my y values, which is f of x, is 3. So that is the point, right? So this is the key. You'll be able to identify point, identify slope and concavity by just look at the table. We do more practice on this, and hopefully it makes sense when we get to do practice this Monday. So I'm looking at 5, f of x, which is the y values, which is 3. And then to write an equation, we also need the slope. So the slope at this point is 2. You look at the next one, right? Slope means first derivative. So if you write an equation, you have slope and a point, just put them together. So y minus 3 equal to 2 x minus 5. And that is the equation of tangent to the curve of f of x at x equals 5. Well, hopefully this helped with your homework on 3.4. And please post question on Edmodo's if you have question for Ms. Conan and I, and get ready for Monday to ask us question. All right, see you Monday.